Okay, and welcome back. So for those of you that just need a quick reminder, and you already know this pretty well, but you just need to remind yourself of which is which. To get the x-intercept, just set y equal to 0 and solve for x. And to get the y-intercept, just set x equal to 0 and solve for y. Okay, and I took the liberty of writing down a few forms of equations that you can get on an exam. So if you look at this one here, this y equal mx. So that's the first type of equation you can get. So an example would be like y equal 3x, or 3y equal x, or 2y minus x equals 0. The second type of equation you can get would be y equal mx plus b. Okay, and an example would be like y equal 2x minus 1, or 3y minus x equal 1. Now those make diagonal lines, okay? So that means that that means the line crosses both the x and the y axes. The last two, y equal b, which is this one here, or x equals c, basically b and c are constants. So for y equal b, an example would be like y equal 4 or y equals 0. If that's the case, you're dealing with a horizontal line and there is no x-intercept, and the y-intercept would just be a number. And then for x equals c, again, c is just a number, so x equal 3 or x equals 0, that'd be an example. If that's the case, then you're dealing with a vertical line, and there is no y-intercept. And the x-intercept for that would just be equal to the number that you're given. So in this case here, the x-intercept would be equal to 3. Okay, so on the left over here, I have the x and y coordinate system. Over here is just the y-axis, and over here is just the x-axis. So the reason why I drew the y-axis this way and the x-axis this way is so that way I can make better sense of y equal b and x equals c. Sometimes students are confused as to what's a horizontal line and what's a vertical line. So I would consider this kind of like, these are like trick questions. And the reason why is because maybe teachers assume that you're so experienced with graphs that you just kind of know, that the equation for a line can be constant and that you just know whether it's horizontal or vertical. So I'm going to get these out of the way, these y and this x-axis. I'm going to get these out of the way real quick and just explain how we're going to use them. Okay, so let's graph the example y equal 4, right? So this would be a horizontal line. So if it's y equal 4, then we're going to look at the y-axis, and so 4 would be located right here, right? And you just lay your pencil perpendicular to that, okay? And that means that you're dealing with a horizontal line. So therefore you draw it on your x and y axes as a horizontal line, right? I'm going to erase what I just drew so that way I can do the x equal 3 example, okay? So now let's look at x equal 3. Well, that's going to be a vertical line, right? So let's look at the x-axis. So at x equal 3, somewhere around here, well, that's going to be a vertical line, right? Because you have to lay your pencil across the x-axis. So that means on your normal coordinate system, x and y coordinate system, you just draw your line at x equal 3, right? See, now you can see the difference between the horizontal and the vertical lines, right? So this would be, actually I'm going to write down x equal 3 here. Let me write that a little bit better. So this would be x equal 3, and the other one was y equal 4, so 4 is somewhere up here. So this would be y equal 4. So if you were asked on a test to graph these two lines, y equal 4, x equal 3, then these would be the x and y intercepts. So in this case here, this x-intercept would be at 3, 0, and this one here would be at 0, 4, right? All right, so those are the two tricky ones. Now let's get into the standard equations that we're normally asked to find the intercepts for. So this y equal mx type form or y equal mx plus b type form. So these are diagonal lines. So an example would be this one. 3x plus 2y is equal to 6. Okay? Now you don't have to isolate the y. You could just leave it the way it is because all we want to know is where the x and y intercepts are. So this equal sign is like a fulcrum on a scale. Basically, it balances out the left side with the right side. So it's always in balance. So moving 3x to the other side as a negative 3x is not going to change anything. The balance is still going to stay level, okay? Okay, so let's get the x-intercept. And we know that the x-intercept, you get it when y is equal to 0, as you see up here, right? Okay. So that means that y is going to be equal to 0. Let me write that a little bit better. Okay, so to get the x-intercept, let's just go ahead and start off by writing the equation out again and substituting the 0 in for the y. So that's going to be 3x plus 2 times 0, which comes out to be 0 here for the 2 times 0, and that's equal to 6. So instead of rewriting this again, I'm just going to divide by 3, and then as 3's cancel out, and I get x is equal to 2, which means that my ordered pair is going to be x, y equal to 2, 0, right? Because y is 0 and x is equal to 2. So therefore my ordered pair is going to be 2, 0. Okay, now let's get the y-intercept. And we know for the y-intercept, x will be equal to 0. All right, so we're going to get 3 times 0, which becomes 0 there, plus 2 times y is equal to 6. And we can divide by 2. 2's cancel out, and we get y is equal to 3. So therefore, this ordered pair is going to be equal to 0, 3. Now let's graph this. All right, so for the first coordinate pair, we have 2, 0. So that's going to be about here, and this is going to be 2, 0, right? I'm not going to write the little tick marks. Just get used to that, actually. You should get used to not writing the tick marks. The reason why is because it'll save you a lot of time, especially when the equations are not located around the origin, where you only have to write down like 1, 2, 3, 4, 5. Just approximate it. Okay, it's just good practice. And for the other point, so this would be point 1. So this would be point 1, and this would be point 2. Okay? And so 0, 3 is going to be 0, 3. So that's about here somewhere, right? And I'll just go ahead and write that in here. Okay, now I just draw a line to go through them, and that'll be the equation of the line. Okay, so let's try to interpret what these intercepts mean. Like, what is the point of this in real life? So for this y-intercept, we could say that maybe the company started off at the very beginning, right, with an investment that it made of $3 million, right? So that would be, this particular point here would represent the time at 0 and the investment of $3 million. And as time goes by, so I'm putting little tick marks here, as time goes by, well, the investment just wasn't that great, so they ended up losing money. And so after let's just say 2 months, or maybe 2 years, whatever, so this would be like years, let's just say, they ended up broke, right? And that's where this amount would be the dollar amount, this 0 right here, right? So if that's the case, then sometimes you can think of this kind of like a money situation, right? And everybody likes money, right? All right, so what's another way we can look at this? So this is kind of a fun little thing to think about. I'll put this on another page. Let's think of a dating situation, right? So most people are interested in somebody, right? After a certain amount of time, they kind of get disinterested, so eventually you break up, right? So this could be for boys or girls. And so this y-axis would represent the interest level. So the higher you are on the y-axis, the more interested you are in the person. And this would be the amount of time that goes by. And so on the last graph, this was the point 0, 3, and this point here was 2, 0. Okay, so let's take a look at this graph one more time. So your interest was oh, here's something. I didn't derive the slope-intercept form of that last equation we did. So I'm going to go ahead and do that right now. So it was 3x plus 2y equals 6. So I move the 3x over. I get 2y is equal to negative 3x plus 6. And divide by 2, and I get y equal to negative 3 halves x plus 3. Okay, so now we're going to let y equal the interest level. And time will be, we're going to replace the x with time. So we have this plus 3, right? So let's look at how interested are you guy or the girl in the very beginning? So we're going to let t equal 0, right? So we want to know what the interested level intercept is. So that would be like the y-intercept, right? And you see where this is going, right? Because if you let this equal to 0, this will cancel out, and you'll get an interest level, I guess, or interested level of 3. And that's the maximum. That's where you guys are all happy and you can't wait to see each other. You guys are sending notes to each other and you talk forever on the phone. Okay, great. So that's great. Now, after a certain amount of time, you get disinterested and you want to know when that happens. So if that's the case, you're going to set the I equal to 0. And so this right here gives you the I-intercept. And now we want to know what the t-intercept is, right? So I'll separate this here. So the t-intercept is when I is equal to 0. This one is when t is equal to 0. Okay, so that means I is going to be equal to 0. So that's going to be 0 is equal to negative 3 halves t plus 3. Move the negative 3 halves t over. So that becomes 3 halves t equal to 3. And multiply by the reciprocal, so you get t is equal to 3 times 2/3. And 3's cancel out, and so t is equal to 2. I mean, we did this already, but just so you could see it with different variables. So that means 2, right? So after about 2 months, you've seen everything you need to see, and you are done with that person. I mean, it could be 2 weeks. I mean, I remember somebody was interested for 2 hours, and then they broke up. Anyway, that's just an example. So, you can apply this to dating, So anyway, I hope that you are somewhat inspired by that example, and we'll have something you can relate the algebra to now. So I got a couple of conceptual questions for you. The first one would be question number, I'll call it bonus question 1. And that would be, when are the x and y intercept values the same? So let me write that out. Okay, so that's the first question. So I'll give you a second to think about it. Okay, so the question basically is asking, when you solve for the x-intercept and the y-intercept, that each one has the same number, right? So that's a situation like this. You have a x and y coordinate system, the Cartesian plane, and this is your y and this is your x. So this would be like 2 here, and this would be a 2 here. And it means that the line crosses through both those 2 points, right? Well, if you look at the slope of that line, that's a -1, the slope of -1. So that means your equation would look something like this, right? However, notice that it's shifted up or shifted to the right, however you want to look at it. So in that case, that's just some kind of offset b, right? So this would be the answer for that. So y equal -x plus b. And to prove that it is, the x-intercept would be such that y is equal to 0. And if that's the case, then you'll have 0 is equal to -x plus b, so therefore x is equal to b. And for the y-intercept, x would be equal to 0, which means that y is equal to 0 plus b, so therefore y is equal to b. So notice that x is equal to b and y is equal to b, so that means they share the same, that means they have the same intercept value. Now, question number 2, I'll just put it right here. This one's easy. Okay, and I'll give you a second to think about that. All right, so the answer for that, I'm going to put it right up here. The answer for that is the origin. So it doesn't matter where your line is. It could be this way. It could be that way. So essentially, your answer would just be any form where y is equal to x or y is equal to negative x. It doesn't matter. As long as it looks like that, then you're fine. So there could be a number in front of the x too. So you could have like y is equal to mx, where m is positive or negative. Okay? So this pretty much covers it. And that's pretty much it, really. I guess this was kind of a little longer than I expected, but I think it'd be worth it in case you get somebody clever that decides to ask that question. But if you look back at everything we did here, I tried to cover every single possible situation you'd ever encounter for this level of math. This pretty much covers everything. I can't think of anything else that I could add into here that would be that essential where you would need it because something wasn't explicitly explained conceptually, meaning that the concepts that I'm showing you here are enough to do any problem. Like you should be able to get through any situation of any problem, okay? And I've also related some of the concepts of the intercepts to real life situations, so I hope you find that helpful. Anyway, that pretty much covers everything. Well, as always, good luck with your homework and tests in the future, and thank you for watching.